is an introduction to scatter plots and bivariate relationships. Why this chapter is important for us? Because in this chapter, we're going to learn about regression line. Regression line actually gives us a linear relation between X and Y. When we're talking about linear relation, it means that we have Y equals to M times X plus another constant like B. So Y depends on X. This is the value, the number that depends on X. So X is independent variable. And Y is called dependent variable. Y depends on X. In any cases, M, slope of the line, is a number, and B is called the y-intercept. M and B, these two are both numbers. For example, you might see linear relations like y equals to 2x plus 1. M, or the slope of the line, is 2, and y-intercept is B. Or you might see y equals to negative 0.3x plus 2. Your slope is a negative decimal number. But again, this is just a number. This is your M, and your y-intercept is 2. When it comes to regression line, we have a lot of X values. To construct this relation between X and Y, first, we're interested in visualizing the relation. Remember that if slope of the line is positive, you have increasing line. The line is increasing. We read graphs from left to right. From left to right, your graph is going up. On horizontal axis, we have our X, and on vertical axis, we have our Y. So if M is positive, we have uphill, increasing line. When it comes to statistical analysis using regression line, we don't have the nice graph that you see here. Instead, we have a lot of dots in the plane, and this line is the line of the best fit that fits into the data. That's why we call it regression line. If our slope is negative, however, we have downhill or decreasing line. So in algebra, we learned that, hey, this decreasing line is a nice graph like this. From left to right, our line is decreasing. In statistics, we don't have this actual nice graph. What do we have instead? We have a lot of points in the plane. Then we find this nice equation or the line of the best fit for our data. This is our goal in Unit 6. So what are the basics? Let's take a look at the terminologies. Introduction to scatter plots and bivariate relationships. Introduction. In the United States, the Food and Drug Administration requires nutrition information labels on most prepared foods. The nutrition information like sugar, vitamins, fat, etc. can tell you whether you are eating a healthy nutrition or not. We will begin this lesson by examining data gathered from the nutritional labels on boxes of breakfast cereal. Below are the nutrition labels for 3 cereals. Look over the labels as you might do it in the grocery store. Well, okay, let's take a look at these information that we have. Nutrition facts, which one is healthy, which one is less healthy, which one is the best. So here you have information about total fat, about sodium. What else? We have information about protein, vitamin, and so on. Okay. We usually focus on calories and then we check the fat. Some people are interested in knowing about the sodium and sugar, maybe protein. Okay, these are the information that we have here. The very first question is, which of the 3 cereals do you think is most nutritious? What nutrition information did you use to help you make your decision? Well, okay. I do care about sugar. 14 grams, that's too much, that's very high. So between these 3, my pick is going to be the third one based on the level of sugars. Next steps. Consumer Reports magazine reviews and rates many products, including breakfast cereals. It reviews and rates the products to help people make informed buying decisions. The magazine uses its own criteria or standards and does all its own product testing. Consumer Reports is published by a nonprofit organization called the Consumers Union, whose mission is to work for a fair, just, and safe marketplace for all consumers. Good to know. We will now explore the Consumer Reports nutritional ratings for 76 breakfast cereals. Consumer Reports uses a rating system with a scale of 0 to 100. Below is the distribution of Consumer Reports ratings for 76 cereals. As you can see, we have numbers on the horizontal axis, which shows the ratings, and each dot on top of these numbers. As usual, let us ask some questions. What does each dot represent in this distribution? Okay, each dot represent, remember that we have 76 cereals. Each dot represent one kind of cereal. For this distribution, what seems to be an average rating? Okay, take a look at this distribution. You see you have an outlier down here. And then what is the center? What is the balancing point? What is the typical rating? That's the question. What is the typical rating? If somebody asks you, okay, you're a statistician, you collected the data about the ratings for 76 cereal, but okay, give me just one number. What is the typical rating? Among all of these ratings, what is the typical value? What is the center? Well, your answer should be a number between 40 to 45. It seems like the center is around 40 to 45. 40 to 45, approximately. We're doing our best without doing any calculation. By looking at the data, the distribution that we have, the center is between 40 to 45. The next question, what is the range? So we ask a question about the measure of center. Measure of center. Now we're interested in asking question about the measure of variability. So remember that the measure of variability, the very first one was the range. Range was the difference between the maximum value minus the minimum value. The maximum rating here is, seems like it's 94 minus the minimum rating, which seems to be 17, 18, which is 76. And as you can see, most ratings, most dots are in between. Okay, most dots maybe in between 20 and doesn't go this far. 60, 61, 20 to 60, 61. The majority of the data, the most of the data are around here. Let's go to the next page. Using the dot plot, we were able to answer questions about the overall ratings of the 76 cereals. Next, you might wonder how cereal ingredients, such as sugar or fat, relate to Consumer Reports rating. Yeah, that's important, how they rated these cereals. Even though Consumer Reports does not disclose its rating formula, we could investigate this for ourselves using information from nutrition labels on cereal boxes to investigate how two variables are related. What's the meaning of that? How sugar relates to the rating, how fat relates to the rating. So it means that how variables are related to each other. We need a new type of graph that they call scatter plot. Scatter plot. Well, the scatter plots in supplement A for this lesson show the amount of an ingredient in the serving of a cereal and the consumer reports rating for that cereal. Each graph has 76 points, one for each of the 76 breakfast cereals. For example, in fat and rating scatter plot, each individual point corresponds to a particular cereal and shows the fat content and rating of the cereal. Let's take a look at the sample scatter plot. This scatter plot here shows relation between sugar in grams and fat in grams. If we change the relation between two variables like sugar and rating or fat and rating, we create more scatter plots. There are numbers on the horizontal axis and there are numbers on the vertical axis. Based on the relation between X value and Y value, you construct a graph that we call scatter plot. In some cases, we try to predict the value of one variable using another variable. The predictor or explanatory variable is on horizontal axis or x-axis. So the predictor, explanatory variable, or independent variable. So these are the names that we use for our independent variable. Independent variable, predictor, or explanatory variable is going to be on x-axis. Response variable or dependent variable is on the vertical axis. So response variable or dependent variable is on vertical axis. Well, in our example, we think that a cereal's fat content may affect its rating, of course. In the fat rating scatter plot in supplement A, we're going to discuss it later, the explanatory variable is a cereal fat content and the response variable is consumer reporting rating. So on the horizontal axis, the amount of fat, and on vertical axis, we have the rating. If you're interested in checking to see what is the relation between the amount of sugar and rating, sugar goes on the horizontal axis, and on vertical axis, we're going to have the rating.